Hello, my name is Farah Al-Sayeh from Princess Sumaya University for Technology. In this question, we are going over LC match network for a given load. The question is, a load ZL equals 30 plus J30 is to be matched to a 50 ohm line. Design a matching network and specify the values of L and C at a frequency of 1 GHz. So first step, we find the ZL small, which is ZL capital over 50 ohm, that is Z node, equals 0.6 plus J 0.6. So this is the Smith chart. First, we find the point ZL, which is 0.6 plus J 0.6. 0.6 plus J 0.6. And that point is ZL. To find the admittance of this point, you read this point through the blue lines, which is 0.8 plus J 0.8. YL equals 0.8 plus J 0.8. To find YL capital equals YL multiplied by 50 ohm, that is Z node, which equals 40 plus J 40 Siemens. To match the network, we want to go from the load point through the red and blue lines to this point, the matching point. So I chose to go through the red line anti-clockwise to this point, calling it ZA. And clockwise through the blue line to the matching point, ZM. If we go clockwise in the red line, we add a series inductor. Anti-clockwise, we add a series capacitor. If we go clockwise in the blue line, we add a shunt capacitor. If we go anti-clockwise, we add a shunt inductor. So as I went anti-clockwise in the red line, I added a series capacitor, and clockwise in the blue line, I added a shunt capacitor. To find the values of ZA of the capacitor and the inductor added, or in this case the two capacitors, first we find ZA in the admittance and the impedance of ZA, which is 0.6 plus J 0.5, and in the blue line it is 1 plus J 0.8. And Z match is 1 plus J 0, because it's the matching point and we want it to be real. So to get the capacitor value, we get ZA 0.6 plus J 0.5 as seen before. YA equals 1 plus J 0.8. So for the capacitors, we find ZA minus ZL, which equals minus J 0.1. And then we find by this rule, minus J 0.1 equals 1 over J omega C. And omega is 2 pi F, and F is given in the question, which is 1 gigahertz, which equals 2 pi times 1 gigahertz equals 6.28 gigahertz. And by substituting the W or omega in the equation, we find the capacitor value, which is 1.6 nanofarad. And then Ym minus Ya, which is minus J 0.8. Minus J 0.8 substituted in this equation, we find the second capacitor equals 20 nanofarad. So first, as we moved anti-clockwise in the red line, we added a series capacitor with the value of 1.6 nanofarad and a shunt capacitor as going clockwise in the blue line with a value of 20 nanofarad.